All right, today we're going to go on a bit of a wild journey. We're going to build our entire reality. I'm talking about the screen you're looking at, the room you're in, the whole world outside, and we're going to build it all from the absolute smallest, simplest idea imaginable. So let's just jump right in. How do you do that? It sounds kind of crazy, doesn't it? But honestly, that's the beautiful, mind-bending question at the very heart of geometry. How do we get from the idea of, well, nothing, to the substance of everything? Let's figure it out. To build a universe, you need some basic ingredients, your building blocks. In the world of geometry, our blocks are points and lines. These are the absolute fundamentals that everything, and I mean everything else, is built from. Okay, let's start with the point. Now, this thing is just a pure idea. It's not the physical dot you see on the screen. It's the concept of a single perfect location, like a pen on a digital map. It has no size, no dimension, it just is. It's kind of like the ghost in the geometric machine. So what happens if we take that ghostly idea of a point and just stretch it? What if we line up an infinite number of them, one after another? Well, you get a line. And see those arrows on the ends? That's the super important part. They're telling us this thing doesn't just stop. It goes on forever in both directions. But an infinite line isn't always what you need, right? So we've got a couple of variations. On the left, you've got a ray. Think of it like a flashlight beam. It has a clear starting point, but then it just shoots off forever in one direction. And on the right, we have a line segment. This is what we actually use to build things. It's like a piece of string. It has two definite ends and a length you can actually measure. Okay, so we've got our basic pieces. Now we need a place for them to exist, a sort of canvas to build on. And in geometry, we call that a plane. This is where our lines finally get to interact with each other. So what exactly is a plane? Just imagine a perfectly flat tabletop that just never ends. It goes on forever in every direction. It has length and width, but absolutely zero thickness. It's our infinite two-dimensional playground, the stage where all the geometric action is about to happen. And this is where it gets really interesting. On this infinite playground, our endless lines can really only do one of two things. They can intersect, meaning they cross at one and only one exact point. Or they can be parallel. Think of railway tracks. They run side by side forever, always the same distance apart, but they are destined to never, ever meet. So we have our pieces and we have our playground. Now it's time to stop just talking about things and to actually start building things. We're going to take those line segments, our measurable pieces, and we're going to start connecting them to create our very first real objects, polygons. But wait, you can't just slap any lines together and call it a day. Nope, there are rules. A recipe, you could say. First, the shape has to be totally closed with no gaps. Second, absolutely no curves. We're talking only straight line segments here. And third, they have to connect cleanly, endpoint to endpoint, to form nice, sharp corners. Okay, so based on that simple recipe, let's ask a quick question. What about a circle? Does it follow the rules? Just think about that second rule for a second. And yeah, the answer is a big fat no. A circle is all curve. It completely and beautifully breaks rule number 2. Which means, and this is fascinating, it's not a polygon at all. All right, so let's focus on the simplest, but maybe the most powerful polygon you can make, the absolute champion of shapes, the triangle. And here's why it's so important. It's incredibly rigid and strong. You can't just bend a triangle easily. That's why you see them everywhere. They're the backbone of bridges, skyscrapers, and even bike frames. It's strength in its purest form. Now we've got a couple of easy ways to sort triangles. The first one is just by looking at the length of their sides. Super simple. If all 3 sides are the exact same length, we call it equilateral. If just 2 sides are equal, it's isosceles. And if all 3 sides are totally different lengths, it's scalene. The other way to sort them is by looking at the angles inside. The corners. If all 3 corners are sharp and pointy, less than 90 degrees, it's an acute triangle. If it has one perfect 90-degree corner, like the corner of a square, it's a right-angled triangle. And if it's got one big, wide-open angle, more than 90 degrees, we call that obtuse. And that brings us to a really crucial, unbreakable law of triangles. You can never have a triangle with 2 right angles, or 2 of those big, obtuse angles. It's just geometrically impossible. And why is that? Because the 3 angles inside any triangle have to add up to exactly 180 degrees. Every single time. There's just no room in that budget for more than one big angle. So we've pretty much mastered the three-sided world. Now it's time to level up. We're going to expand our universe by adding a fourth side to create quadrilaterals. And then we'll finally go back to that beautiful rule breaker, the circle. Quadrilaterals are just a fancy name for four-sided polygons. You know most of these already. The square is the most famous, 4 equal sides, 4 perfect right angles. A rectangle is like its stretchy cousin. It still has 4 right angles, but only the opposite sides have to be equal. And the rhombus, that's like a square that got kind of pushed over. All 4 sides are still equal, but the angles aren't 90 degrees anymore. They're all part of the same family. And now we're back to the circle. It might not be a polygon, but it shows off a whole different kind of perfection. A circle is just the collection of all the points that are the exact same distance away from a single center point. This is why you see it everywhere in nature, from ripples in a pond to the planets in the sky. It's the most balanced shape there is. So let's just do a quick tour of its parts. The center is the anchor, right in the middle. The radius is that constant distance from the center to the edge. It's the circle's most important measurement. The diameter is just 2 of those radii stuck together, going all the way across. A chord is any line that connects 2 points on the edge, and an arc is just a little piece of that perfectly curved boundary. And here it is, the simple, elegant, powerful little bit of code that runs every single circle in the universe. The diameter is always exactly twice the length of the radius. If you know one, you instantly know the other. It's just a beautiful, universal truth. So, we actually did it. We went from a single imaginary dot all the way to lines, to the strength of triangles, and the perfection of circles. So now for the final thought. I want you to look around, right now. At your desk, out the window, at a building, what's the most complex thing you can see? You need to realize that you can now break that thing down into the simple, fundamental shapes we just built together. That's the incredible power of geometry.